upper areas of the media and in the mulch layer, you really need very, very little media in order to get at these 3 pollutants. Really a 1 foot depth is fine. Phosphorus, 2 foot minimum, 3 foot would be nice. Nitrogen, you really need 3 feet and an internal water storage zone if you can. I'll talk about internal water storage in a little bit. And then temperature, do y'all have any trout streams in the northeast part of the state? Yes? Okay, so you do have some areas where you care about stream temperature. Really, 3 feet is the absolute minimum for stream temperature. For temperature mitigation, you probably want 4. We've even got some cells in our mountains that have 5 feet of media. The more media depth you have, the greater will be the heat transfer that occurs between the media and the water. Okay, media selection is another important part, and y'all will have another workshop specifically on this and vegetation later on next month. But it is a very important part of bioretention design and how the bioretention cell is going to function. So the ideal media composition is really, it really varies depending upon your pollutant that you're trying to capture. So if you're looking at temperature and N removal, you really need a greater hydraulic retention time in that media in order to get at treatment of those 2 pollutants. So 1 to 2 inch per hour media is what we would recommend for an infiltration rate for those 2 pollutants. If you're looking at other sediment-bound pollutants, TSS, fecal coliform, phosphorus even, if those are your pollutants of concern, a greater saturated hydraulic conductivity is just fine, 6 inches per hour or more. Yep.
Yeah, temperature reduction.
Mm-hmm.
Okay, what's the purpose of that?
So if you have cold water fisheries or cold water habitat, which you do in the northeast part of the state, trout and salmon species are, they basically are killed off when water temperature gets above 70 or 75 degrees Fahrenheit. And so of course the runoff coming off of the parking lot outside the building here could be 100 or more degrees Fahrenheit. And so if you can get some temperature mitigation in your bioretention cell before the water gets transmitted to the stream, then you're going to do less impact on those trout streams.
So how are you transferring that in your bioretention?
So what happens is the soil is a certain temperature. Usually when you go about 3 feet below grade, it's about 55 degrees Fahrenheit year-round. And so if your water is 100 degrees Fahrenheit, let's say, or 95 degrees Fahrenheit coming in, you're going to get heat transfer to the soil particles as the water is filtering through your media. So the water temperature will decline. And we've done substantial, I'll show some data on that later. We've done a substantial amount of research on that.
But you're just passing it slower through the media.
Correct.
So it cools down.
Correct.
Longer time to cool down.
Exactly. Exactly. So that lower infiltration rate gives you essentially more contact time with the media, and therefore you get more heat transfer. Yep.
Is that an issue in Atlanta?
I don't think so. You don't have any trout streams around here, right?
Yes.
Okay. Well, I'm not. Are there local regs for temperature mitigation at all yet? Not yet. Okay. Okay. Yeah. So for TSS, you're really fine with a much higher conductivity through your media. Phosphorus is another big one in North Carolina. Y'all don't have too much phosphorus concerns here, or do you?
They're in some of our TMDL.
Okay. Okay. So the key thing with bioretention media with phosphorus is to not get a media that already has a lot of phosphorus in it. So when you apply fertilizer for, let's say, 50, 100 years on an ag field, you're putting a lot of phosphorus into that soil, and it gets basically chemically bound onto the soil, and when you run a lot of water through it, like we are with these media filters, it ends up like a tea bag, and you take a lot of the phosphorus off, you strip a lot of the phosphorus off of the soil, and your phosphorus concentrations actually get worse as they move through, and I'll show some data on this as well, as they move through your bioretention media. So what we have in North Carolina is what's termed a P index. It's a soil property that can be tested for. I think us and New York are the only 2 states that use it. Most people use a Malick 3 test. That's what's typically used, and I would bet that's what, if you took a soil to a soils lab here in Georgia, that's what you would get, is a Malick 3 test done. And so what we want is something between 12 and 36 mgs per kg phosphorus in our soil media in order to get good phosphorus mitigation as the water moves through the media. Obviously, we're not in North Carolina, so you wouldn't submit it to NCDA. So here's what I'm talking about. There's 5 bioretention cells here. The one in Charlotte I showed you earlier, the 2 in Lewisburg, and then 2 in Greensboro. And you can see the p-index it's basically on a 0 to 100 scale, so it makes it simple for farmers to figure out how much fertilizer they need to apply. In this case, we're using it to look at how much phosphorus is in our media. And so you can see these 3 here have very low phosphorus indices. This is more moderate, and then this is very, very high. And you can see the effluent concentration of phosphorus increases substantially, right? This is a factor of 10 or more, 15 or more greater than our lowest concentration here. So this really does have a big impact on phosphorus performance. And so if you do care about phosphorus in whatever watershed you're working in, this is really a key thing to look at. So media selection is absolutely critical with phosphorus. With good media, you're going to get very good total phosphorus sequestration, typically in the upper layers of the media. So our ideal mix in North Carolina, after a lot of trial and error over the last 10 or 15 years, this is what we've come up with. It's 85 to 88% sand, 8 to 12% fines, which is the clay and silt fraction, and then 3 to 5% organic matter, which is typically like pine bark fines or some other form of organic matter that's going to last a long time and be recalcitrant in the soil. So it's a very, there's not a lot of organic matter in that, right? If you gave that to a soil specialist, they would tell you this needs to be fertilized. But we have a lot of water coming to this bioretention cell. It has a lot of nitrogen and phosphorus in it. And so the water is what's going to take care of your plants. Plant growth is not a problem at all in this. We've had years and years of experience with it and no issues with plant growth. Question?
You get much phosphorus in urban fertilizing, because a lot of people the agriculture's in the south part of the state, but in the north part of the state, there's a lot of landscaping.
Yep. Yeah, I mean, there's phosphorus in a typical bag of 10-10-10. There's phosphorus that's part and parcel to that. There are some states that have gone away from, like Florida, it's 10-0-10 now, so there's no phosphorus in their fertilizer that you buy in Home Depot. So it depends on what state you're in. I'm not sure what Georgia's, can you still buy 10-10-10 here? Yeah, so you do definitely have phosphorus. And you will see substantial spikes in concentrations of runoff concentrations when you're monitoring these things after fertilization occurs.
But if you have phosphorus because you have runoff from planted areas, fields or lawns or whatever, but these particular designs of infiltration are specifically for rooftops and parking lots.
Yep.
And so unless you're having phosphorus air pollution for the rain to come down, that shouldn't be an issue.
Yeah, you get atmospheric deposition of phosphorus. And so what happens is because you're concentrating, let's say 10 times more watershed area into this small bioretention cell, you actually do end up with a relatively large mass of phosphorus in the system. Because the volume of water times your concentration, which I agree the concentration of phosphorus is low, but the volume of water is quite large. And so you end up with a large mass of phosphorus that comes into your bioretention cell. Yep. It's a good question. So soil texture on our media is typically either a sandy loam or a loamy sand. That's all I want to say on that. It's a very sandy soil media. Underdrains, do you need an underdrain? In most cases, absolutely. Our minimum cutoff is actually 4 inches per hour, so it's substantially different from the 0.25 inches per hour that you mentioned earlier. So if you have, basically this means if you're on the beach or close to the beach in North Carolina. Yep.
In the solid mix placement, what level of compaction is there?
Can I get back to that later?
Yes.
Okay, I'll get to that. Under drain configuration, this is the internal water storage zone that we were talking about. This is the best example of the pipe that I can show you. So what we have here, these are the under drains at the bottom of the system. In this case, we have a 2-foot internal water storage zone. So this is going to force water to be stored up to this invert elevation in the media. So what that does is it causes an anaerobic zone if you don't have soils, if you don't have highly infiltrative soils underneath it. It will cause an anaerobic zone in here, and that will kickstart your denitrifying bacteria to get rid of a lot of the nitrogen that is coming through your bioretention cell. So this is absolutely used a lot in North Carolina, and it is credited more than a standard configuration. Your standard drainage configuration, of course, would just be a flat under drain coming into this outlet structure right here. Again, we've got a 90-degree elbow here. So this is our new design guidance cross-section, gravel layer with an internal water storage zone. Typically, it's greater than 12 inches, 18 or 2 feet. You do need 3 feet of media, really, to pull this off. That's one design consideration.
On that previous slide,
Yep.
back, is that at the end, is that at the end of the pipe for checking it, so there looks like there's a stand pipe at the end.
This right here?
No, at the
Right here. That's a clean out. That's a clean out. So that's so you can drop like a, we've never had problems with under drains getting like roots or anything in them like you would with a sanitary sewer, but that's so you can drop like a roto-rooter or a camera down to see if you've got clogging of your under drains. So it's maintenance purposes. Yeah, this is HDPE. I would prefer to see PVC personally, but it is, in this case, it is HDPE. Question?
You said underdrains are generally required all the time.
Unless you've got greater than 4 inch per hour.
Cost. Can you address sort of where you would draw that line?
We would draw it, if the underlying soil has an infiltration rate greater than 4 inches per hour, that's where the line is drawn in the sand.
What would be the risk of not putting an underdrain in if you have well-drained soils and a safe way for the water to exit if it ponds?
Yeah, I mean, if you have well-drained soils, that's just fine, but
I'm sorry, well-drained soil media.
yeah.
Why so?
If there's no underdrain under the bioretention media, and you've got, let's say, a 0.05 inch per hour infiltration rate, pretty low, you're going to have water in that system for days and days and days, and it's going to turn into a wetland rather than a bioretention cell. You're going to end up getting hydrophytic vegetation, wetland soils form, because you've got long-term ponding. There's nowhere for the water to go if you don't have underdrains. Because the only two places for the water to go is really into the underlying soil or into the underdrains if there are some, or overflow into the drop structure. So you can also get overflow into this drop structure as well. In this case, this is a geotextile, not something we would typically recommend, but that was put in. This is a DOT picture. These tend to get clogged with silt and clay, and so we don't typically use them in our installations.
One thing to mention, the design manual does say 0.25 inches per hour infiltration, but we recommend underdrains on every bioretention. Just during construction, compaction happens, and we'd rather it be conservative, have conservative design, have overflow.
I mean, I can't imagine underdrains would be more than 5 or 10% of your cost. I mean, the media is really the large portion of the cost.
So is that an underdrain as well?
This is an underdrain, yes, with an internal water storage zone. So the water level has to get up to the bottom of this pipe in order to get drainage through the underdrain.
But is it pervious so the water can get into it?
Correct, yeah. The pipe is perforated. Question?
The internal storage area, how is that sized appropriately to not have that same wetland condition? If you don't have a good drain soil below, it's still going to just be sitting water.
Can I get to that in a couple slides? Sure. Cool, awesome. So this is our typical design cross-section. A couple of things that are other ancillary benefits of internal water storage. Of course, your invert elevation of your underdrain is going to be 1 or 2 feet higher, so it's easier to make connections to existing storm drain boxes. Whereas with conventional drainage, you may not have a deep enough storm drain network to connect. And then if you're just daylighting the pipe, of course you have less excavation and less cost there with internal water storage as well. So it's just a 90-degree upturn in the PVC. You can see the perforation here, perforations in this PVC pipe. It's a 90-degree solid upturn that creates that anaerobic zone in the soil. Here's another example of one. This is just a monitoring apparatus here, but it would typically just be this PVC pipe. So we like to say it's the best $25 you've ever spent in a BMP. It's not costly, right? It's an elbow and another straight piece of PVC. Very simple, very easy to do. Show you some quick data here. We had a couple of bioretention cells in Rocky Mount. We had 2 internal water storage zones, a shallower one here, 2 1/4 foot deep, and then a deeper one, 3 1/4 feet deep. And I'll show you what the data looks like, the water balance for 2 years of study for this particular cell. I'll mention the underlying soils are sandy here, so we got a lot of infiltration. You can see with the shallow, or the deep IWS, I should say, we have more infiltration, 82% infiltration versus 68% with the shallower IWS, because with the shallow cell, you only have to have 2 1/4 feet of ponding within the system before you get outflow. With this, you have to have another foot, so you have to have more water come into the cell before you get outflow. So the deeper cell, again, has more infiltration. So the deeper your internal water storage zone is, the more infiltration into the underlying soils you are going to get. This also works in clay underlying soils. So The Rocky Mount cells that I just showed you are these two right here. You can see the number of events with outflow is very, very small in both cases. However, these Greensboro cells, these are in our typical hydrologic soil group C, sandy clay loam type soils that we have in the Piedmont of North Carolina. And you can see no IWS. We had 2/3 of the events have drainage through the underdrain versus only just under 1/3 have drainage to the underdrain when you have that internal water storage zone. So it's not only a benefit to nitrogen, but it's also a benefit to the amount of outflow that you get from these systems. You're forcing more water to drain into your in situ soils. So that's a big benefit for stream health. Getting to your question now about separation and making sure that the internal water storage zone will drain. Like I said earlier, you really need a 3-foot media depth to pull off these internal water storage zones because they are going to be 18 or 24 inches deep typically. And so what you need is you need an area of aerobic media at the top of the bioretention cell so that your plant roots can grow, right? Typical plant roots, unless it's a water-loving plant, are not going to do very well in anaerobic soil. So what we say is we need 12 inches of separation from the bottom of the bowl to the top of the IWS for A or B soils. And then for B, C, or D soils, we give it 18 inches of media before you get to the top of your internal water storage zone so that you have that aerobic layer in the soil that allows the plants to grow and thrive. Does that make sense to everybody? So that's our typical guidance for that. Pretreatment, do you need pretreatment? Yes, you have to have pretreatment. I would absolutely, I'd come out all for pretreatment. You can use a 4-bay, you can use a filter strip, you can use a manufactured device. What I would say is if you're doing your calculations, you want to limit your inflow velocity to 1 foot per second, especially with filter strips, because they will start to erode above that 1 foot per second value. So some examples of 4-bays, here they are. You can use rock. You can, in this case, this is just turf reinforcement matting. What I want to mention is if you have an internal 4-bay, and it's kind of hard to see, but this is the bioretention cell right here, and the 4-bay is part and parcel of that bioretention cell. You need to line that 4-bay with an impermeable liner, like a pond liner, because otherwise what will happen is the water will come into your 4-bay and it will short circuit and go straight to the underdrain that is in the media right here. And so it will bypass essentially any treatment in the media. So if your 4-bay is part of the bioretention cell, please line it with that impermeable liner. You can also use swales. It's another application here. This is typically going to be residential and not ultra-urban, obviously. This is a picture that I took. I'll say it. It was in California. Pretty amazing. Can you all make out what that is? Gabion Baskets, yeah. How cheap do you think that was? Not very. How effective do you think it is for pretreatment? Not very. Yeah. These are really ugly, right? And they are, you're really going to only get filtration through the bottom, inch or two of that gabion, and the rest of it is a total waste. So, yeah, this was more or less a joke. Please don't do that. Mulch does matter. You do need mulch in these systems. When you have a tree shrub mulch type system, there's a lot of benefits of them. They provide moisture for plants, obviously very similar to what you'd have in a typical planted bed. You have pollutant removal that occurs in the mulch layer. There's a lot of organic matter, and so therefore you do get out hydrocarbon and metal removal in this mulch layer. And then obviously aesthetically it looks more pleasing as well. We do recommend double or triple shredded hardwood mulch. That's because that tends to lock together and hold in place the best of any mulch. If you use like pine bark chips, they tend to float, they don't interlock, and so you get a lot of mulch loss down your overflow structure the first time it rains real hard.
Do you use that on their farms, or they
Yeah.
grass?
Well, yeah, I would say the majority of the DOT beds are tree shrub mulch, and so they do use mulch, yeah. They do have some grass systems as well, though, as I showed you earlier.
Yeah.
Yep.
Count as your 2-3% organic in the mix?
No. No, that's on top of the 2-3% organic, yeah. So we recommend a 3-inch mulch depth, typically, is what's recommended, 2 to 4. You are going to get floating in mulch. There's just no two ways about it. If anyone knows of a mulch that's really dense and doesn't float, please let me know. We'll make lots of money together. It'd be great. One cool thing that I've seen, the city of Charlotte, this picture's not showing up very well, but you can kind of make it out here. This is the drawdown orifice. This is 12 inches off the top of the media, and you can see what they've done here. They've put a metal screen over that to prevent any of the mulch from going down and draining out through the outlet structure. And this is what I was also talking about earlier. We've got our 12 inches of ponding right here. 12 inches of ponding right here. And then this additional 6 inches is for peak flow mitigation. That makes sense to everybody? Question? There's a question.
If you got a contractor wants to clear and grub a site, whether it's a tub grinder or a film chipper,
Yep.
and then use it for his erosion control and various other things, is some of that green mulch applicable in this case, or does it have to be compost?
We tend to like the double or triple bedded better because it's more fibrous and it tends to lock together better. That's the reason it just holds up better and doesn't float as much. It floats, but not as much. So that's what we prefer to have. I'm sure there are cells that go in out there that do have some mulch that's on site, yeah. Yeah. I'd prefer to see double or triple shredded hardwood though. Question?
Back a few slides that we were talking about, the picture of the DOT, it had the liner, that was the
Yep.
fabric liner.
Yep.
So you don't recommend any liners?
If you're up against a building, I would absolutely line it. Or if you've...
Fabric permeable.